Hey guys, in this one we're looking at our first set of geometric sequences and series exam questions. So all the formulas we need are in here too, and let's go. Okay then, number 1, Alan is creating a mosaic pattern by placing square tiles next to each other along a straight line. The area of each tile is half the area of the previous tile, and the side lengths of the largest are W centimeters. Part A. Find the side length of the second tile. Alright, so we know the area of the first tile will be W squared. So the area of the second tile will be W squared over 2. Now the side length is the square root of that. So the side length is the square root of W squared over 2. So that's W over root 2. And for part C, Ellen decides it will look better if she leaves a 3mm gap between the tiles. We want to explain how we could refine our model used in part B to account for the 3mm gap and state how this will affect the total length of the series of tiles. Alright, so after the first tile, she's gonna need a 3mm gap for each additional tile. So we could say for n tiles, she needs to add n minus 1 lots of 3mm to the sum for the length. Alright, so that's how we can refine our model. Now, as for how it affects the sum of the total length, so in part B we were dealing with a sum to infinity. So we were thinking if a pattern had an infinite number of tiles, which obviously in real life it can't, but thinking mathematically, if she has an infinite number of tiles, she would need an infinite number of 3mm gaps. So what this means, theoretically, is that there is not necessarily a limit to the total length of the pattern. Number 2, in a geometric series, the common ratio is R and the sum to n terms is Sn. Given that the sum to infinity is equal to 8/7 times the sum to 6, show that R is plus or minus 1 over root k, where k is an integer to be found. Alright, so what we're going to do is use the formulas for the sum to infinity and the sum to 6. So, the sum to infinity is a over 1 minus r. Now we know that is equal to 8/7 times the sum to 6. So that's a times 1 minus r to the 6 over 1 minus r. Alright, now both sides have a common factor of 1 minus r on the bottom. So we can multiply through by 1 minus r. So we get a is 8/7 times a lots of 1 minus r to the 6. Now, both sides have a common factor of a, so we can divide through by a. So we get 1 is 8/7 lots of 1 minus r to the 6. We could multiply through by 7 and divide through by 8. So we get 7/8 is 1 minus r to the 6. We can now add r to the 6 and subtract 7/8. So we get r to the 6 is 1/8. Alright, nearly there. Now, you can either use your calculator at this point, or both sides are a cube number, so if we cube root both sides, we get r squared is 1 over 2. So then square root and we get r is plus or minus 1 over root 2. Number 3. Find the value of the sum from r is 4 to 20 of 20 times 1/2 to the power r. Alright, so Edexcel are really annoying at this. They like to use r when we need it for something else. So I'm going to think here of r as n, because we need r because we have a geometric sequence. So I'm going to think of this as the sum from n is 4 to infinity of 20 times 1/2 to the power n. Alright, so that is the sum to infinity. So from n is 1 to infinity. Minus the first 3 terms. So minus the sum from n is 1 to 3 of 20 times 1/2 to the power n. Alright, so let's see. So A is going to be 20 times 1/2. So A is 10. And R is 1/2. Alright, so our sum to infinity is going to be 10 over 1 minus 1/2. Now that's 10 over 1/2, so that's 20. Now our sum to 3 now that's easy to work out. That's 10 add 5 add 2.5, so that's 17.5. So we then have 20 minus 17.5, and that gives us 2.5. And guys, that's it for geometric set 1. I got a couple more questions for set 2. Hope to see you there. Take it easy. Take care.